Welcome to another geometry lesson. This is 3.8, an exploration lesson on find and use the slopes of lines. So before we get started, go ahead and make sure that you have out your student notes and your vocabulary graphic organizers. And I'm going away. Let's begin. So here we go. Interior designers use lines and slope to design room arrangements. What do you think that could mean? And in a minute, I want you guys to show us. Okay, perfect. Someone said that whenever things are in a room, they can imagine that there are lines there so they can make sure that things are placed evenly so that your furniture doesn't look crazy. Loving it. Could you show us what you mean? So are you ready to use your imagination? All right, so down below in just a minute, you are going to see a slide with your name on it. You're going to find your slide and you're going to do exactly what you said an interior designer does. You're going to move your furniture around the room. Of course, you can scale it if you need to because a love seat has no business being the same size as a mirror. Actually, it could be if there's a very nice big mirror, but maybe not an armchair and a plant. But anyway, you're going to go ahead and arrange your room, and then be prepared to talk about what you did and how that applies to slope. Ready? 3 minutes and go. Okay? So we are back, and let's hear from Clara Jones. And fun fact, that is my grandmother's name, Clara. Okay, perfect. She said that she had her furniture arranged, and she noticed that she could put a line through her furniture. And that would be the way that she knew that she had things arranged in a way that made sense and looked good. Very nice. So let's keep going. Consider this problem. Keely is an interior designer. The floor plan of part of a client's office is shown. Keely suggests that the client should place an armchair at the point that partitions the segment from the center of the bookcase to the center of the table in a 1:2 ratio. What should the coordinates of the armchair be? All right, go ahead and mark up that text and be prepared to explain it to me in 3 minutes. Perfect. All right, so going ahead, I had someone talking about her placing an armchair. They said they don't see an armchair, so that must be what she's trying to place. Someone said that there is something at a point and that they see some points here. Perfect. All right, I had another person said it's the point, but what point? The point that partitions the segment, so that's the piece, from the center of the bookcase. Perfect. And someone saw a bookcase there. Okay. So it partitions the segment from the center of the bookcase to, oh, perfect. Someone said if it's going from someplace to someplace, it must be a line. I love it. If I'm going from here to there, from A to B, from bookcase to where? Nice. To the center of the table. Where's the table? Where's the center of the table? Yes. So someone said that must be my points. And that Keely must be recommending that her client puts the armchair between these 2 points. Nice. Okay. And someone said that must be a line. I love it. So I'm going to make a very feeble attempt at drawing a line. Yeah, it's kind of straightish. And that armchair has to go somewhere along those lines. Okay. Someone said it's probably going to go about there. All right. And the question was what? What should the coordinates of the armchair be? And before we get there, how did you know that this is where the chair might go? Okay. Someone said because they saw that line and they saw there was an intersection there or a point there and a point there, so this point would go on those lines. We'll see. Okay? And the question it's asking us is, what should the coordinates of the armchair be? Okay, perfect. Yes, I see that someone noticed that coordinates are just when I put my X and then my Y. Whatever's in my X, on my X axis or on my X coordinates and my Y coordinates. So what are the coordinates for this point? Oh, perfect. My X equals 1 and my Y equals 4. So let me go ahead and put that. I've got 1 and 4. Nice. Those are the coordinates of the bookcase. And someone says we know what else? The coordinates of the table. How many over did we go to get to this point? We went over 11 and up 2. So my coordinates are 11 and 2. And we need to know, yes, the coordinates of the armchair. Now, we absolutely do not have to solve this now. We can solve this in a bit because we are going to learn about a formula to help us solve that. Okay, perfect. I don't know why I can't get that to stretch. Yes. There was that question. Someone said, I don't know what 1-to-2 ratio means. Okay. We will figure that out. But does anyone know or remember what a ratio might be? Okay. A ratio is almost like a relationship between two amounts or two distances, any two numbers in relation to each other. So like if you've ever been cooking and someone said, well, use 3 parts flour and 2 parts water. You ever heard of that? Use 3 parts flour, or, for example. Right. So that means that if you use 6 parts flour, then you need to use 4 parts water. So as one thing increases, another thing increases. What are you guys noticing increasing in relation to something else here? Oh, somebody has said a decrease. Okay. Well, what do you notice is changing something else? Someone said that line is going down at a pace. And it's going down at a diagonal pace. So maybe there's something that's influencing something else because otherwise it wouldn't be steady. Technically, it isn't steady because look at my line. I'm joking. It is supposed to be steady. All right, so let's keep going. So you can describe a line by describing the vertical and horizontal change called the rise and run. You can use the rise and run to determine the slope, compare lines, and find a point that divides the distance between 2 points according to a ratio. And there's a picture of it. All right. I want you guys to get with your groups and take about 4 minutes to talk about and mark up the text and go. All right. Some people brought me back some things and they're saying that a line, and we see the line right there, describes the vertical and the horizontal change. Oh, change that color. Will do. Let's clear it all. Okay. So a line, which we see, describes the vertical change, but not just the vertical change, but also the horizontal change called the rise and the run. Oh, nice. Someone automatically related that. They said that vertical means it's going up and down. That's what a rise does. It goes up and down. Perfect. And what else? Horizontal. There we go. Horizontal. Yes, it goes side to side. So it's that change in that. Perfect. So someone else noted that whenever I put together my vertical and my horizontal, I get a diagonal line. Yes. Perfect. Okay. And what do we see in the second part of this definition? Okay. Someone said that you can use the rise and the run, that I can use the rise and the run to do what? To determine the slope. Perfect. So rise and run are used to, oh no, okay. Almost tried to live stream, my bad. That rise and run can be used to determine the slope. And here we go. Oh, perfect. Someone said it reminds them of ski slopes. Yes, and if this is where I started, puffing hard uphill, aren't I? But yes, this is me changing, not just going one direction, and definitely not going straight up. That's not a slope. But yes, my vertical and my horizontal change together. So I can use that rise over run to determine the slope. What else can I use it to do? Compare lines. What do they mean? So if there was another line going beside it, whether or not that line had the same slope. Okay. And what else? Perfect. Someone else said, find a point that divides the distance between 2 points according to a ratio. And there's that ratio again, which is what? Relationship. Perfect. So let's imagine that we've taken a trip, or that we're taking a trip, right? And so, of course, this, I don't know, might be the border, so that might be a starting point. But where are we starting our trip from? Okay, someone said we're starting it from New Mexico. And we're going to where? Perfect, New York. If I'm thinking about where that is on a map, am I just going to go that way? Am I just going to go that way? No, because why? Well, because New York is up there. Oh, it's up, so I can just go up. No, okay. So someone says I need to go up and over. Is that what I should do? Go up and then over? Oh, go diagonally. So for every what? Someone said that for every number of miles or points that I go east, I have to go a certain number of miles and points north. There we go. So I'm dividing that distance between 2 points according to a ratio. And a ratio, remember, is a what? A type of what between two numbers or distances? A ratio is a relationship. It is a relationship. So I can't just say, yeah, drive 500 miles west or drive 500 miles east. It's not going to get me there. For every 500 miles that you drive east, you'll drive 200 miles north, for instance. So yes, that relationship or the distance between 2 points, and it's divided into a ratio so that no matter where I am, I know if I need to get back on track on this line, I just go this many numbers or this many miles east for however many miles I went north. Okay, so let's jump into it. Let's find out about slopes of lines so that you can solve this problem on your own in the career preparation exercises. So the objectives for your graphic organizer. In this lesson, you will find and use the slopes of lines. That is one. You will find the slope of a line. You will use slopes to identify parallel and perpendicular lines. And then you will partition a directed line segment. All right, so let's keep moving. And slope of a line. Oh, I see some people pulling out graphic organizers. Perfect. So the slope of a line is a measure of the line's steepness. It is the ratio of the vertical change, the rise, to the horizontal change, the run, between any 2 points on the line. Mark that text up and go. Okay, perfect. Someone said that slope equals steepness. Perfect. How steep it is. I also see the ratio, which is going to mean the what? The relationship. And if there's a ratio or a relationship, that means that one thing does what? Relates to the other, or one thing affects the other. Don't ask me why I decided to write out this line with the trackpad on my finger. Okay, there we go. Or write out this word. Okay, perfect. Somebody said vertical change. Let me do that in another color. Vertical change, which is the rise, and horizontal change. So the ratio of vertical change to horizontal change, which is the run, between any 2 points on a line. Perfect. So someone said this is finding out the distance between 2 points. Yes. And that vertical change I know is called what? Yes, it's y, or at least the vertical point, and the horizontal point is x. Perfect. Anything you need to write in your graphic organizer? All right, let's move on. If x1 and y1 and x2 and y2 represent the coordinates of 2 points on a line, then the slope represented by the variable m is m equals y2 minus y1 over x2 minus x1. Go ahead and mark that up. 3 minutes and go. Okay, perfect. Somebody started with 2 points on a line. Okay, and so that means if I've got a line, I'm looking at 2 different points on it. Yes. Here we go. 2 points on a line. Okay. And then someone says, then the slope is represented by variable m, and variable means it's able to vary, right? And so this can change. Yes, so if that's variable m, then I should be able to plug in anything along this line and still get that same ratio or that same answer. Or a form of that same, ratio of that same answer. Perfect. So what did someone notice? Okay. Someone said, this doesn't look like a coordinate. Or what do you mean? Oh, okay, you're saying this part doesn't look like a coordinate and it looks different from that and you wondered why. Okay. So let's draw it out. So what do you see first? Okay, you see that there's X and Y and you recognize that, right? So we're gonna call it X1 and Y1. Okay, and what else? Okay, someone sees X2 and Y2. Ah, you said you're getting it now. Perfect. Yay, X2 and Y2. Surprised you're getting anything with this handwriting. So Y2 minus Y1, yes, that's how you found out the change in the rise. Yes, yes, yes. Ah, okay. Someone said that they have heard of rise over run before. Rise over run. So yes, I subtract Y2 minus Y1 to figure out how much it went up, but then X2 minus X1 to figure out how much it went over. So it's just like dividing my Y and then dividing my X. Perfect. And this is the formula for it. All right, so let's look at it. What do you notice happening? Okay, take about 3 minutes to discuss it with your group. Perfect. Okay, so someone said they noticed here that this was my X1. And in order to get to this, I went over 1 and up 1, and that's where I got these coordinates. Perfect. And there's another point. See our 2 points? And in order to get those coordinates, I went over 7 and up 5. Perfect. And so here is my measure of the slope. I had Y2. So this Y2 was up what? To 5, okay? And then Y1 was 7. So this, was 1. So this is where I got my 5 minus 1. And then for my X2, I had what? I went over 7, and then here I went over 1. So I have 7 minus 1. There we go. Where did I get that 4 minus 6? Okay, someone said that, not 4 minus 6, but 4 over 6. I saw the change. There we go. And then it reduced to 2/3. So the slope of that line is what? 2/3, or the ratio 2 to 3. So for every number of points that I go up, I go over 3. Yes, that's right. And guess what? This is how you know that these things are related as ratios. 2 over 3. Or look. Fraction. And these are the same dots as ratios. So for every 2 that I go up, I go over 3. See? 2 out of 3. 2 out of 3. 2 over 3. That's right. Perfect, perfect, perfect. All right, so knowledge check, and you can use your graphic organizers if you took notes. So here we go. You are going to find your group's slide and you are going to match. So whichever these pictures or definitions represents the rise and run, you put them there, and whichever ones represent finding the slope of a line, put them there, okay? And go ahead and find your group slide. Take about 5 minutes to put these in the correct positions and go. All right, so here are the answers. And yes, that is correct. So here we go, rise over run, vertical over horizontal change, you see it, rise and run. And you can use that to determine the slope. And here we see it being used to determine the slope, which is the measure of the steepness of a line. Perfect. All right, it's vocabulary time. So if you have not filled out your graphic organizers, go ahead and put some definitions, defining properties. Go ahead and fill that out. 4 minutes and go. Or you can give me a thumbs up when you're done. All right, moving on. So we're talking about the slope of a line again, but now we're talking about some properties of it. So make sure that you go ahead and drop these back in your graphic organizers. All right, so the first thing I see is that a slope of a line can be positive, negative, 0, or undefined. And this here is a what? It is a positive slope. How do you know it's positive? Okay, someone says it goes up from left to right. Yeah, so that's the way we read, right? So that's the same way that we start reading our slope. And I see that it went up. That is a positive slope. And a hint, well, I won't even use that hint now, but yeah, I can use the hint. So the hint is usually if you can write your name on the line, then it means that it's positive. And so because my name is, well, you know what? I'm going to write my name. Kiana. Oh, yeah. Oh, no. Come back. There we go. I'm like, is this my sign to leave it alone? No, I'm going to finish my name. Or not. Okay. There we go. Now, if my name is not going to fall off the line, if it were to keep going, it's positive. Now, of course, we're not talking about it sliding backward, but no, it's not going to fall off that line. That line's going to go up and up forever. It is a positive slope. How about now? This is a negative slope, and the line goes down from left to right. So if I started going from left to right from where I read, oh, that line went down, didn't it? It is negative. And if I were to write my name on it, my name would slide right off. All right. This right here, the slope is 0. There is no slope. If I go from left to right, this line is not sloping. It's going straight over. And if I'm on a ski, yeah, I'm not going anywhere. Perfect. All right. And here it is undefined. It is undefined. It's not that there isn't a slope, because this here, there is a slope. But here, that y value, it keeps changing. So I can't even determine how far it's going to go. There we go. It's undefined. All right. So go ahead and find the slope of each line. Go ahead and do this with your group. Back in 3 minutes. Go. All right. So let's go ahead and look at how this was worked out. Here we go. So I've got x1 and y1 equals 1 and 5. So x1 right here, if I'm on the x-axis, and I found my x point, the first one, I'm over 1. And I'm up 5, so there's my coordinates, 1 and 5. And here are my coordinates, what? 3 and 1. There we go. And so if I have those coordinates, can I fill them in? Not doing so hot with that. If I have my coordinates, can I just fill them into these spots? So y2 was what? It was 5. Okay. Oh no, I'm sorry, y1. I'm looking at x1. This is why this is not x2. It started up here. Although it really doesn't matter. You just have a negative if you subtracted it the other way. But here's my x1. So I can put a 1 right there and a 2. So my x2 started off with 1. There we go. And I put that there. And my x1 is 5. There we go. I'm sorry, my y2 is 1 and my y1 is 5. Now my x2, my second x is 3. There we go. First x is 1. So if I subtract this, 1 minus 5, I have a negative 4. 3 minus 1 is 2. So my slope is negative 2. It's going down. Perfect. All right, let's go to the next one and find the slope of this line. Oh, somebody already said it's undefined. And this is how I know. One of these, any of these is going to be on 0. So let's see how we'll figure that out. If I start with x2 and x1, so let's go ahead and do our coordinates. So the coordinate of this one is what? And I'm sorry, it's not undefined, it's 0. The coordinates of this one is x is what? 0. And y is 4. Oh, it's over here. That's right. Thank you. Okay. So x is negative 1. And y is 4. Perfect. That's my first one. All right. And how about my second one? X is what? 5 and 4. So x is 5. Y is 4. Wow, I mixed up my 4 with my parentheses. Really, people? Okay. So I'm going to call this what? My x and y1. So I'm just going to call that number 1. And this one is number 2. Here we go. So if I look at my y2 first, I have what? 4. There we go. And then my y1 is 4. So 4 minus 4. And then for my x's, my x1 is 5. And I'm subtracting it from my x2, which is negative 1. So 5 4 minus 4 over 5 minus negative 1. And those two just cancel each other out, so it may as well be a plus. 4 minus 4 is 0. 0 over 6 is nothing. There is no slope. Because any number divided by another number is nothing. All right, so let's find the slope of this. Perfect, perfect. Somebody said, let's look at my first set of coordinates and my second point. My first point is what? 2, negative 1. Perfect. 2 over 2 down negative 1. And my second point is 6 and 1. 6 and 1. And someone gave me my formula, which is what? M equals what? Y2 minus Y1 over X2 minus X1. Perfect. And what is Y number 2? It is 1, okay? Minus the first Y, which is negative 1. So minus negative 1, which is just like plus 1, over my second X is what? 6 minus what? 2. Perfect. And 1 minus negative 1 is just like 1 plus 1, which is 2. 6 over 2 is 4. And if I reduce that, it goes to 1/2. Ah, yes. Okay, perfect. And is this slope negative or positive? Well, right here we see a positive number. So yes, it is positive. Plus, if it goes from left to right, it's going up. And find the slope of this line. All right, perfect. Someone said, go ahead and let's do my 1 and 2. So there's my point 1. There's my point 2. For point 1, my X is what? 2. It's over 2. And my Y is what? 3. And for this point, my X is what? 2 again. And my Y is what? Negative 4. Oh, somebody said, uh-oh, what was that uh-oh about? I have 2 of the same number in X, which is going to be a 0. But didn't I have a 0 before and that just meant no slope? Isn't that what it's going to mean? No, it's not? Okay, let's see why not. So let's look at my formula. M equals what? Y2 minus Y1 and X2, or over X2 minus X1. Perfect, perfect. So Y2, my second Y is 3. Here we go. Minus my next Y, so that's minus negative 4. All right. And then my X1 is 2. Oh, that's the problem. Someone just said that's the problem. So 3 minus negative 4 is just like 3 plus 4, which is 7. Put over 0. And I can't have a denominator of 0. You can't ever have a part out of 0 because you had nothing to start with. So if you had nothing to start with, then it is what? It's not 0. It's undefined. Because you cannot have 0 as a denominator. Because otherwise, this isn't even a real number. What? Can't divide nothing into 7 parts. Aha! So there we go. And that was negative 7. Missed that? Yes. So negative 7 over 0 is an undefined slope. All right, guys, so did you know that occupational health and safety specialists use slope to determine whether ramps in workplaces are safe and appropriate? Do you see him going up this ramp? What would happen if it was too steep? Yes, he would have trouble getting up it. And if he's having trouble getting up the ramp because it's too steep, yes, he might get tired and roll backward. That is a hazard to his safety. Yes, and what happens if there's no slope? Well, perfect. If this is the ground and this is the door, he's never going to get to the door. All right, so you're going to try finding the slopes of lines on a graph. You're going to work with your group for 5 minutes to complete pages 1 through 4 in your Build Your Skills section in P2C. Ready and go.